Welcome to another episode of CUDA Education. Today we want to discuss creating another instance of an object in the ray tracing context. So in a ray tracing application, you have an instance of a triangle, one triangle that's being displayed in your application. You want to make two triangles. You want to make another instance of that triangle, also known as two triangles, right? Another instance of the triangle in that same application. And what we want to do is discuss how you go about doing that. How do you go about changing the application so that you have another instance of a triangle in the ray tracing application. And basically the reason I stress a ray tracing application is because for a non-ray tracing application, it's a little different, or maybe even a lot different. But there's a distinction between a ray tracing application and a non-ray tracing application. Because ray tracing is all the rave, and GPUs and processing power and all that good stuff is all the rage, and we're capable of doing this stuff. Naturally, the world is moving more towards ray tracing and having more photorealistic graphics in your applications, whether you're talking about scientific applications, business applications, obviously video games, simulations, etc., etc. So that's what we want to tackle in this video, and I kind of have a new approach, which I'm sure you guys will enjoy. Before we start with all of that, first want to encourage you guys, if you haven't gotten tutorial number 1 or tutorial number 15, I believe it's 15, tutorial number 1 and tutorial number 15, please go ahead and do so. I do provide these free YouTube videos, so I do a little bit of both, but please support the channel, support all that we're doing, all of our efforts. Tutorial number 1 is basically installing the Vulkan API on your Windows-based machine. So you have to have a Windows-based machine and a Vulkan-capable GPU. So a Windows-based machine and a Vulkan-capable GPU, you will be able to install the Vulkan API. That's tutorial number 1. And it's a video tutorial kind of like this, where I walk you through the process of installing a Windows-based application on your the Vulkan API on a Windows-based machine, right? So you could run Vulkan and do all what we do here. Tutorial number 15 is installing a bunch of Vulkan examples, kind of like this one here, or basically like this one. So it goes through installing all of these examples, and what happens is that because you have all these examples installed on your machine, you're in a better position to learn Vulkan, right? So there's a lot of setup, there's a lot of boilerplate stuff, there's a lot of things that go into actually getting Vulkan to run, and to actually even just get to see something on a screen like a triangle. So I really encourage you guys to install at a minimum. I mean, you could always get the series, but at a minimum, get tutorial number 1 and tutorial number 15, so you could actually, hit the ground running, as they would say. All right. So, definitely, maybe even set up a group, maybe have a bunch of friends and you guys tackle it together. It's way more fun that way if you have people involved. You could play video games but also learn how to create them too, right? So it's a good thing to learn, just in general. All right, so the topic at hand. So we are basically talking about creating an instance of an object, a second instance of an object in an application. So our default application, this is the ray tracing basic application, which you could see here, ray tracing basic, right? So that's the application that we have. And then when I run the application, basically you see that it's a triangle, right? You could zoom in and out. You could turn it around, all that good stuff. But it's an instance of an application of a one triangle, right? So that is that is ray tracing basic, right? And it makes perfect sense. So that's pretty much what we have here. Okay, nothing too crazy, right? You've seen this a million times before. All right, so that is the application. I'm running a GeForce RTX 450 laptop GPU. We're running at 1017 frames per second, depending on whatever, right? Ray tracing basic. All right. So, okay. So what I'm gonna do is basically now I'm gonna basically copy and I'm gonna put in another script that so I copied and pasted another script that basically what it does is you'll see. So now in our application we have two triangles. Okay, so there's one triangle and then there's another triangle, right? We have another instance of a Vulkan application of an object in Vulkan. Okay, we've used Vulkan to do all of this. I the basically the code is changed as minimally as possible, and basically what we're trying to do is basically create another instance of an object in a ray tracing application. So we have our first triangle and we have our second triangle, right? So the topic of this video is to dissect how we go about doing this. And my approach is to do it in the least amount of code as possible. So even if you look at just the way how the camera is set up, notice the camera is focusing on this triangle and not necessarily this triangle. I have not attempted to make the application nice, so I haven't adjusted the default camera angle or the camera lens or where the camera is or how the application opens up, or I haven't even changed the colors of the second instance, right? It's the exact same thing. It's just been transformed to a different location so we could actually see that there is another triangle there, right? So I'm trying to be as minimally invasive as possible, almost like a surgeon, right? Minimally invasive. So yeah, the idea is to basically just create another another triangle, and that's it, right? And we try and learn from this. Okay, so that's where we're at. So let me go back to the original. Let's go back to the original application, and we're back at the original, right? And notice that it by default it defaults to centering on the triangle, which is, naturally with the other application it starts out with the other triangle being here, but we're still centered here. Okay, all right. So that's basically that. All right. So here is how we're gonna learn what changed in the two applications. All right. So we have on the left the application with one instance, so one triangle, and we have on the right the application with two instances, so two instances of the triangle, the original triangle and then the other one on the right hand side. Okay, and we're basically going to comb through the two applications and see what changed. Again, the goal of this the goal of this video and this the way how I did it was to be as minimally invasive as possible. So you could see right here that It's really only a couple of lines of code that have been changed in order to get a second instance. Okay, so we have our first instance and we have our second instance. Now, in previous videos, I will link the video below in a whiteboard edition, the whiteboard edition video that I did previously. It's called the ray tracing overview, or how ray tracing works in Vulkan. We talked about rays traversing a scene. And in the ray tracing lingo, in the ray tracing world, we have top level acceleration structure and bottom level acceleration structure. I did not invent these words. These were words that were bestowed upon the people from the Vulkan gods. And there's a distinction between top level and bottom level. So the bottom level acceleration structure is basically the geometry of the triangle. So let us just run our application again. So the bottom level acceleration structure basically is just the geometry of the object, right? So in our case, we have the geometry of a triangle. So we have a point here, a point here, and a point here. 3 points make a triangle. They're connected, all that stuff. That generally is considered part of the bottom level acceleration structure. I talk about it in more detail in the whiteboard edition video. I'll find it and put a link to it below, and you guys could dive more into it. The top level acceleration structure deals with one of the main focuses of the top level acceleration structure is dealing with the instances, the number of instances of the object in your application. So, obviously, in simulations, especially graphic simulations like video games and stuff, you start to get into, you need to duplicate an object multiple times. So, for example, if it's a flight simulation, maybe or a first-person simulation, you have clouds, right? And you have one cloud, you have another cloud, you have another cloud, blah blah blah, right? And you want to create many instances of that cloud. Or you have mountains and you want to create many instances of those mountains. Or you have trees, or you want to create many instances of those trees. Or you have lakes, or whatever it is, right? And you want to do it in the cheapest way possible, meaning that you don't want to rehash and recreate every instance of that object from scratch. You kind of just want to make a copy. Maybe you make minor modifications, but basically you have one instance and you make copies of that instance, and then you make minor modifications, right? It's cheap, and when I say cheap, I mean it's less processing power, it's less memory operations, less memory transfer, less time, and ultimately, a better graphical experience, because your frame rates aren't gonna drop. There's not gonna be lag. You're not gonna see things drawing as you traverse through the landscape, or the you fly through the clouds or whatever. Things are seamlessly and it's done as cheaply as possible. So again, the Vulkan gods have these they have these this concept of a top level acceleration structure, and all it is making multiple instances of an original object. So this is our original object, and as you can see in the previous when I did the I guess I'll just do it here. As you can see, what we're doing now is we create another object, right? And obviously I'd have to move it over a little bit, but we create another object, a copy, another instance of the same object. So this is our original, and this is the instance, and this is done by the top level acceleration structure, right? So that's basically that's basically what we're trying to tackle in this video and in this application, right? So we're back to our original thing right here. So let's get to work. So the version of ray tracing basic that I have is probably an older version. So if you go to GitHub, if you Google Sascha Willems ray tracing basic, and you pull it up on GitHub, you're gonna get a slightly different version of the script than what I have. Now in GitHub, you could cycle through the older versions and see the one that I have. So if you search for it online and you see that the code is a little different, don't freak out. It's just that I have an older version of the application, because when I installed my solutions, it was, way back in time. So it's slightly different, but it's not a make or break thing. It's just that, you'd have to choose the older version of the script. Okay. But let us proceed. So if you see the cursor is here, and as we scroll down, we see that nothing changes, right? So all of the script, nothing basically changes. It's the same thing in instance 1 or instance 2. So then we just go down, we go through all the different things that we've been investigating with all these videos that I post on YouTube. And everything basically is the same, right? Nothing changes. Okay. So now we start to get into some change. As you can see, there's a color difference between the two. So let us dive into it. So in instance 1, we don't have this transform matrix 2. But in the 2 instance application, we do have it. This is just because we this application, the 2 instance application, uses this transform matrix 2 to that's what it uses for what it's trying to do, right? So just like how you have the transform matrix here and here, this version is just the transform matrix 2 is just it's basically for the second instance situation. Okay. So we have the original transform matrix, and then we have transform matrix 2, because we have a second triangle that we have to deal with. We have to move the triangle to a second place in order for it in order for us to see the second triangle. So you're not going to put the second triangle right on top of the first triangle, because then you can't really see the second triangle, right? Because it's one on top of the other. So you kind of have to transform and move the triangle to a different, move it over to the right, so we could actually see that there are 2 triangles there. That's pretty much what it is. And then you could see in the second instance that the transform matrix 2 and instance 2, you're going to see that it's using this transform matrix 2 variable, right? As you could see right here. Okay. So that's the first difference. We'll dive more deep into it a little bit later. We also do a modification here: size of acceleration structure instance, and then so for this basically this is just one instance of a triangle, but now we have to deal with 2 instances of a triangle. So as you can see, there's a difference here. There's also a difference here. So so in the original, in one instance, we only have we don't have to deal with multiple instances, right? Because it's just one instance of a triangle, right? So we're just dealing with the original object. So we don't have to deal with multiple instances. However, in the two instance situation, we have multiple instances. We have the original instance and we have instance 2, right? So the original instance and instance 2, and it's being built inside of a vector. So we sort of have to manage the 2 triangles in our 2 instance situation. We have one triangle and a second triangle. Here we don't have to deal with all that, right? So because we have this vector situation, we also have to modify how we deal with the buffer, because now we can see here that this is the create buffer command. we have to have a buffer where we're dealing with two triangles instead of one. So we kind of have to process managing. We need to have a bigger buffer because we have two. It's two triangles, two instances, whereas here it's just one. So we have instances size, which is 2 times size of VK acceleration structure instance KHR, right? So I assume we're dealing with 2 times the size of. Whereas here in the one instance situation, we just have size of VK acceleration structure instance KHR, right? And then comma, and then we do instance here. So we point to instance, which is this guy up here, VK acceleration structure instance KHR instance. So we just reference instance here, but here we do instances.data. And let us look at, okay, so we have instances, so we have instances.size, right? And we have instances.data. So again, the reason why we have this modification here is because we are dealing with the vector. So here we're processing based on the vector, right? So we're processing the vector instances. In our original script, we don't have a vector. We just have the instance, the original instance. And notice that here we have the instance, and here we have the instance, right? So instances in both situation, but instances, plural instances with the S. See the S here? That's a different variable. Instances is in the 2 instance script because we have to manage the vector, right? So that's where this instances.data comes from, and of course instances.size, right? Because we're managing the vector. Here we don't have to do that. All right. And what we do next is so we have a primitive count of 1, right? Which is because we have one instance, but in our 2 instance situation, we have a primitive count of instances.size. So again, our vector comes into play again, and we're basically counting the number of instances inside of the vector. In our case, it's 2, right? So it's 2 instances of the triangle. So it's doing, okay, the primitive count is not 1, the primitive count is 2, right? And when we do that, we're basically telling the script that, hey, we have another instance of a triangle, so it's 2, whereas here it's just 1. And then we get down to acceleration, structure, build ranging for primitive count. Again, it's the same thing, 1, and 2 here, right? And that's pretty much it. Everything else remains the same in the script. Everything else remains the same in the script. There's nothing that changes, right? So we have our primitive count, and of course we have to manage the vector because now we have two transformations. So let us just play around with this a little bit, because those are all the modifications, right? So let's see what happens first with transform matrix, right? Let's just deep dive. So we have our transform matrix. I guess it stays consistent for the first triangle, right? So nothing really changes. So we have our transform matrix, and we're going through the motions. Nothing changes, right? So the reason why I guess nothing changes for transform matrix is because we still have to generate the first triangle, right? So both applications have that original triangle. So transform matrix deals with that original triangle, right? Transform matrix deals with the first triangle. But then now in our 2 instance application, we have to now transform the second instance, right? And I guess that's where instance 2 comes in. So VK acceleration structure, instance KHR, instance 2, right? So I know I'm saying instance too many times, okay? But here now we translate. So we're saying, okay, we're gonna create another instance. So instance 2 equals instance. So instance 2 equals the original instance. So we have instance 2 here and instance here. So we're saying, hey, the second instance is just like the first instance. However, VK transform matrix KHR. Transform matrix 2, we have a different coordinates, set of coordinates for the second triangle, right? So we have this, and you could see that it's different from the original transform. So this and this, and we do instance 2 dot transform matrix 2. So we're applying this transformation to the second instance. So instance 2. And then we could distinguish it in the shaders. So basically, this is a way for you to basically it's like an index. So you have the triangle 1 we'll call 1, and triangle 2 we'll call 2 or something. Or triangle 1 would be 0, and triangle 2 would be 1. You know, but I don't want to get into this right now because, you know, I don't want to confuse you. So don't worry about this right now. Let's not get into that. But it's just a way of identifying one triangle from the other. It's almost like when you have multiple displays. You have your laptop display and you have your external monitor, and then you go to display in Windows and you say identify display. So maybe the laptop display is number 1, and then your external display is display 2, right? It's a similar concept, right? You're trying to identify one triangle from the other programmatically, so that, like, the shaders, like if you want to do something with the second triangle, you could easily reference the second triangle without, you know what I mean, too much complication, right? But then now, so we have our instance 2 developed. We have the transformation. The transformation was applied to instance 2, and then we create our vector. All right, so we have our vector now, which we don't have in the first thing, and then we just basically manage everything based on the vector. We talk about the primitive count, and primitive count again. I do want to, yeah, I'm gonna dive into this a little bit more, but before I do that, you guys understand now that we have two different transformations. The second transformation is applied to instance 2. Instance 2 is a copy of instance 1, but then we transform instance 2 to beside the first triangle, so we could actually see the second triangle, right? And then we proceed as we need be. We create a vector and we process, you know, instead of just processing directly, we have to process, you know, assuming that it's a vector structure we're dealing with, not just a single object, right? And then we get into the primitive count stuff, which, you know, I'm going to try and dive into in a minute. But one of the things that I want to highlight is that notice that for as big as this code is, we're basically focused on create top level acceleration structure. So this is the function where all of this stuff is happening, right? Create top level acceleration structure. So remember, at the beginning of the video, I talked about top level acceleration structure is dealing with instance related things. So we have an original object, which was created with the bottom level acceleration structure, and now we're just creating another instance of it. So naturally, if you're trying to modify a script, you would focus on top level acceleration structure stuff, because all you're trying to do is create another instance of the triangle. Make sense? Yeah. So that's where all of this, that's why we focus on all of this. And you see these yellow lines are basically centered around the top level acceleration structure. Now, let's see. Okay, so if we look at the bottom level acceleration structure, we see that we actually outline the vertices of the triangle. So these are the vertices of the triangle. And remember, bottom level acceleration structure deals with, you know, you're creating an object, you're creating a triangle. So that's what this is. All right. Yeah, let's just leave that there right now. We're not gonna touch on anything else, right? So the bottom level acceleration structure creates a triangle, and notice there's no difference between either application. It remains the same. But then when we get to the instance stuff, things change. Now, I do want to touch on this primitive count. So we have a primitive count, and then we want to we have this thing called VK acceleration structure build range info KHR. All right, guys, we're getting into it. If you're gonna learn something today, yeah. The spec says this thing is structure specifying build offsets and counts for acceleration structure builds. Okay. We have our primitive count. In our one instance triangle, the primitive count is 1. We have a primitive offset, and this is defines an offset in bytes into the memory where primitive data is defined. This doesn't change in either application. I'm going to guess, and I'm not 100%, but I'm going to guess that the reason why defines an offset in bytes in memory where primitive data is defined. The reason why there is no change is because we're basically replicating the same triangle. So there are no modifications to the triangle, or, there's no like, we're not doing half of a triangle or a piece of a triangle or something. So we're reading the same memory. That's my unofficial amateur sort of a reason for why it doesn't change, but I could be wrong. So there's no primitive offset. Defines an offset in bytes into the memory where primitive data is defined. So it's the same triangle we're dealing with. So we're not, we're not changing. We're reading the same triangle. The first vertex is the index of the first vertex to build from for triangle geometry. So it's the same triangle. We're not reading like, a different triangle or a piece of the second triangle or a piece of the first triangle or something of that nature. Nothing changes, right? Transform offset. So we have transform offset here. Defines an offset in bytes into the memory where a transform matrix is defined. That stays the same between the two applications. I believe we do this separately. So instead of doing, perhaps you could do it here, but we do it separately as we discussed above. We have our transform matrix and our transform matrix 2. So we're not going to use this transform offset to achieve anything. And then everything just basically, we create acceleration build structure range infos. We create our vector with that, but nothing changes between the two. So yeah, so the only modification is that the primitive count changes, so therefore we have to manage that. That's my that's my take on it. If you want to dive deep into this piece of the discussion, just Google this thing right here. Just put this into Google, and you'll get the spec, and the spec will discuss all things related to this. The Kronos group who created Vulkan and stuff, they really don't want people to be duplicating or showing the spec online, so I'm gonna respect their wishes. I guess they do it just for fidelity and accuracy and stuff. They don't want people to be harping about the spec directly and you know, propagating misinformation and all that stuff. So I'm going to respect their wishes, but if you guys want, just drop this into into Google, this term right here into Google, and you will get some information on this. I do want to so we've basically finished the discussion, right? You kind of basically understand that top level acceleration structure deals with deals with the instance, and we have, you know, transform information that's introduced for the second triangle, and we have a vector because we have two instances now, and then we proceed accordingly. So this is not too hard, guys. This is actually pretty. I know I'm 35 minutes into this video, and I was hoping this video to be very short, but I think it's good information that we're discussing. I do want to play around though with sort of the different parameters that are in the updated script. So for the rest of the video, I'm just going to we're gonna just play around with the different parameters, right? And you know, you guys could stick around for it. So okay. All right, so let's play around with this thing. So even though we're in the second script, even though we're in the two instance script, if we simply modify if we simply change, instead of recognizing the vector and all that stuff, if we simply change the primitive count to 1, will everything be canceled? So let's try that. So we're going to just change everything back to 1. Okay, and the script actually runs, the application actually runs, and we just have the first triangle. So simply with this primitive count situation, we could erase all of our changes, right? Because the primitive count doesn't show. The primitive count doesn't see basically the VK acceleration structure, build, geometry, info, KHR. It doesn't see the second primitive because you haven't declared it. Okay, so let us go back to our original situation, right? And we have our two triangles back again. Okay, all right, so that's fine. All right. Let us try and play around with the first vertex. So instead of the first vertex being 0, let the first vertex be 1. Is this going to crash my application and crash this video? Let's see what happens. Nothing changes. I don't think. Yeah, nothing changes. Let's try this. Yeah, nothing changes. So I don't know about this. I don't know about the. Let's try transform offset. Let's see if that does anything. Nothing changes. So I don't know about transform. Let's try 3. Yeah, nothing changes. So yeah, I guess maybe in another example we'll dive into this thing right here. Let us do something a little bit more. So, okay, what happens if we use, what happens if we change the, if we make the transforms the same? So we have our original triangle and we have our transform, to create the second triangle so we could actually see it. What happens if we just make a copy? What happens if we just make a copy, we make the transform the exact same thing? Right? What happens if that happens? All right, you guys guessed it. There's really two triangles in this, but we just see one. Right? And that makes sense because one is on top of the other. Right? Okay. So yeah, when we make it the same transform, it's basically one on top of the other. So the front side is probably one triangle, and then maybe the back side is another triangle. I don't know. But it's basically, there's really two triangles, just that we can't see it. All right, so let's go back to our original situation just to make sure that we're on the same page. All right, so we have our two triangles, right? Okay. All right, let's just change this a little bit more or less and see what we get. So instead of this being 2, we make it 1. All right, so now we get overlapping triangles, right? And this gets really cool, guys. Really cool. So now we have the two triangles and they're sort of overlapping, right? And if we change this to really cool, guys, really cool. So you guys can see. So let's go back to the original. And we're back at our original, right? So now you can see where you can play around with the transform and get different things. Is there anything else worth playing around with? We could change the colors of the triangles and stuff, but I don't want to make this video any longer. I'm already at 43 minutes. So yeah, so I think it's appropriate to end the video here. So we learned about what the top level acceleration structure is. We understood what when they say that a top level acceleration structure deals with the instance creation, we inherently understand what we're dealing with, why we see in a very real way that we have two triangles and we create an instance of the second triangle. So just real quick, we have our transform here, and then we have our second transform that's going to be applied to the second instance. Instance 2 is a copy of instance 1, but we have to transform it. So we apply the transformation to instance 2. We also have to start dealing with vector stuff, because now we have two instances instead of just one object. We have two objects. So normally when you have multiple things of something you create, you put it in a vector so you could like cycle through them and programmatically deal with them and all that stuff, right? So we have a vector, and then we we create the buffer. The buffer now is like memory, and we have, obviously with memory, it's two instances of a triangle now, not just one. So we have to deal with that. And then we get to primitive count. So we have our primitive count. We have our primitive count, and we have to deal with our primitive count as a dealing with two triangles. And then we have our VK acceleration structure, build geometry, info, KHR. If you guys in the comments want to talk about this, because I don't really know too much about this guy right here. Hopefully in the other examples, it will dive into what this thing actually does, or why it exists. So, and that's it, guys. So don't get intimidated by this stuff. There's a lot to learn. No one person knows everything. Vulkan API is a very capable and involved thing, but don't get intimidated. You just take it one small chunk at a time, and you eventually will learn everything. There are a lot of things that I'm sure this serves a very important purpose, but so don't get intimidated if you don't know everything up front. But I'm sure it's an important purpose. Ray tracing is very cool. Invest the time to learn it. Computer graphics is here to stay. All that good stuff. Again, guys, tutorial number 1 to install the Vulkan API on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 15 is for the examples. I'll link all of those stuff below. I'll also link my whiteboard discussion of ray tracing, where I'm on a whiteboard and we just go through, what is ray tracing and in the Vulkan context, and we go through some of the vocabulary and all that stuff, and the camera stuff and everything. And that's pretty much it. You could also get the series where it goes through, creating our first basic triangle, not creating a ray trace triangle, a basic triangle programmatically. We're not shooting rays in a scene or anything, but it's a good way to just learn the basics and the nuts and bolts of Vulkan. Thank you guys for watching. Tell your friends about the channel. You know the deal about the notification bell, all that stuff. I don't like to say it because I hear it a lot on YouTube and it's just annoying at this point, but you guys know what to do. Support the channel, tell people, tell your friends, all that good stuff. Play video games, but learn how to create video games too. All right, guys, have a good day. Bye.